Effect of partial shading. Okay, so why it is occur on PV system? Very simple. So PV panels are, yeah, this is, yeah, PV panels are making with the help of group of cells connected together series like this. What is your
Sir,
what?
excuse me, sir. Mary Prashant, sir. The first
Sir,
aid students, a few first aid students are joining in this meet. Please explain slowly, sir. No problem.
I will explain slowly, sir. Okay.
Yeah, yeah, yes.
So how solar PV panels are making? Solar cells are connected seriously and grouped them, then it is making as a solar PV panel. Okay, so it will be considered each and every box is it will be considered as a solar PV cells. Okay, each cells are each number of cells are connected together, then it will make a solar PV panel. Okay, under normal conditions, so top of the screen that is a diode. It is called as a senior diode, which is connected in reverse bias mode. So I will let you know later why it is reverse bias mode. Okay, right. So under normal conditions, solar panel how it is working based on the available irradiation as well as temperature. So these two parameters are affect the performance of solar PV cells. Okay, right. Under normal condition, so what happened? I connected one load for closed path purpose. Okay. So this dot is represented as a electron will be flow. Okay. Under normal condition, solar PV cells received irradiation from solar what is this, sun irradiation received by solar PV panel. According to the irradiation, it will be generate electrical energy. So how it is electron will be flow? Along with please follow my cursor. Okay. So once it is received irradiations, according to the intensity of irradiation, the electron will be flow. For example, it will flow from positive to these directions under normal condition. Okay. So now why it is the electrons are never moved to this location means here it will be connected reverse bias mode so that it offer high resistance and compared to this path. That is the reason the electron will be moved through this path. Okay, it is a normal operation now. It's a very basic operation of solar PV cells. So how it's working? It will be received radiation from solar from sun. Okay, then it will be electron will be moved to these locations. Okay, this is under normal conditions. In case if any part of the solar PV panel it partially shaded, so at the time what happened? The generation cells act like a load. Okay, that means it is a technically we said that it's a Scott part. It will be appears on solar PV panel when that is a partial shading occur on solar PV panel. What are the possibilities are there for making for occurring that is a partial shadings are for an examples heavy cloud moving over the panel or tree shadow or building shadow. It will be if you fall on the that is PV panel, it will be causes so what is this a Scott spot on solar panel. So already I said that these Scott spots are become slowed, not like a slow source. Why? Because Scott spots means it will generate heat energy. Heat energy when it is generated, when it is become act like a, so what is a load. Okay. So at this situation, so what happened? The electron will be flow through the load and it will be pipe on, it will be through this like okay. It is never moved throughout this location. Okay, it will be followed to the what is a senior diode. That means reverse bias connected diode, and instead of this route. Why? Because of it will offer high resistance and compared to this route. So this is a way we possible to suppress partial shading effect. Okay, so we are incorporate what is this so a senior diode, reverse connected series diode, which is used to overcome partial shading effect. So if you are doing this kind, what is one problem is removed, but another problem is raised due to this. What is this senior reverse bias connected senior diode? It will be create a multiple number of peaks on solar PV curves. Okay, this is a comparison of uniform and non-uniform solar irradiation presentation. Here, x-axis represents the PV voltage, y-axis represents the PV power. You got to see the graph. Green line you got to see, sorry, blue line first you got to observe. It will be increase PV voltage corresponding PV power because of uniform solar irradiation here is 1000 watts per meter square. Because of our land surface is it will be received 1000 watts per meter square purpose. So that it will be at the time of that means high irradiation or adequate irradiation. Here I considered 1000 watts per meter squared as a high irradiation. So at the time the panel capacity is 400 watts, so that it is capable of generating 400 watts. There is no partial shading. Okay. In case partial shading occur, at the time what happen? That is available power will get reduced, as well as multiple number of peak will be occur. Okay. So why this multiple of number of peak is occurred, which is due to the bypass diode. Okay. The role of MPPT is to find which what is n number of multiple peak point is there. Among this, one is has high intensity. So this is called as a global peak point. So role of MPPT is to keep solar panel to working on maximum peak. Okay, where it is available, that maximum peak it is need to work. Otherwise, it is not able to meet what is a high efficiency. This is the role of MPPT. So first, blue line it is represents the uniform solar irradiation conditions, and green line represents the partial shading conditions. Why it is multiple peak is occurred, which is due to the incorporate of a senior diode. Okay, right. So this is conventionally a number of method is there. Okay. Later on, I will go to the non-conventional method. In conventional method, first one the PO is popularly one of the popular method. What is the method name is perturb and observation. Okay, perturb and observation. Here you got to see it is y-axis. Sorry, x-axis represents a 2T cycle. Y-axis represents the maximum power. So it shows a relation between the duty cycle as well as how the maximum power will be vary according to the duty cycle. Okay, you consider as a MPP. This is called as a MPP. MPP means maximum power point. So role of MPPT technique, all the MPPT techniques is to keep working on maximum MPP. But it is not possible to attain this condition to all the circumstances. Okay, due to environment factors, it will be availability may be vary. For example, now if MPPT is at this position, so at the time what happen? Duty cycle, the MPPT algorithm itself, it will be degrees of duty cycle. Okay, once it will be degrees of duty cycle, automatically conduction angle will be increased. Once conduction angle will be increased, rate of change of voltage will be increased. Okay, so that it will be moved from point 1 to towards the MPP. Okay. So very first condition you got to see 0.5. So rate of change of voltage and rate of change of what is the voltage and power, it will be 0. Okay, at the time if this is a condition means the solar PV is working on maximum point. In case if point is this is, that means rate of change of voltage, that is change in voltage and change in power. Okay, why we are using change in voltage, change in power means MPPT is all the MPPT algorithm working based on the previous what is the measurement, what is the instantaneous current measurement. Okay, based on this comparison, it will be working. Okay, now this is a point number 1. First condition it will be checked whether either both the conditions are satisfied. At the time what it do, it is automatically degrees of duty cycle. So once a degrees of duty cycle, automatically voltage will be increased. Once voltage will be increased, the maximum point it will be moved from this point to this point. That means MPPT itself, it will be try to track the maximum power from the available irradiance. This is where MPPT technique is working, especially for perturb and observation MPPT technique. This is a simple plot diagram. I'm not going to specify this is okay. So how can implement MPPT technique with the help of MATLAB? So I'm actually using MATLAB, which is used to demonstrate. Okay, but see, this is our model. Okay, this is a model. In that model, it is a solar PV panel. Solar PV panel. If you double click, you can see all the parameters related to the solar PV panels. Okay, so already I said that solar PV panel output is depends upon the two input. That means irradiance as well as temperature. Here I applied two type of inputs to the solar PV panel. One is constant irradiation as well as variable irradiation to assess the performance of solar PV panel. Okay, right. So once solar PV panel is over, second part is boost converter. Okay, it will be generate a voltage we have to fetch the load is some far away from the destination, so that to avoid what is loss, here I incorporate one boost converter. So this boost converter role is boost the voltage at desired level, depends upon the design. Okay, right. Here one switching device is there. The switching device is controlled by using pulse width modulation generator. So pulse width modulation generator, how it is working? It is based on the MPPT. Here I am using neural network based MPPT technique. Okay. So after that, you got to see here it is called as a filter capacitor. Then here three types of loads I am using. Each loads connected at some certain time interval. Okay. Then I am measuring corresponding voltage, power, and current. Now I go to the demonstration. First, here I said that here it will be going to the now demonstration depends upon the neural network based MPPT. Okay, neural network means it is required two types of input. One is because here I consider what are the input for neural network is temperature as well as irradiance. These two inputs are given to the input to train the network neural network, and output is what is this duty cycle. Duty cycle is output. First I see the 1 second slide. From here, this is an architecture of ANM based MPPT technique. So it recorded two input, that is a temperature as well as irradiations. Okay. Then these are the process. It's an input layer. It will be used to train the neural network. And one output layer, that is output is here not VMPP. Here is a duty cycle. Okay. Then this is where we control the. It is a entire architecture of our circuit. It's a black diagram precision. Here you got to see it's a boost converter arrangement, then switching pulse here. Okay, right. Now I said that it is first we have to train the neural network. So training is adequate for ANN. So that for training purpose, I generate data set with help of this code. So this code is nothing but very simple code. Okay, these are the parameter of solar PV cells. What are the parameters? Short circuit current, maximum current, open circuit current, maximum voltage, current temperature, voltage temperature, and standard irradiations, standard temperature. Okay, these are the what is this nameplate details from the solar PV panel we are collected. This is then we generating 1000 number of datas. Okay, then by using for loop, I am generating 1000 number of datas.
Can you zoom it, sir? Is it? Can you zoom? Fine.
Okay. So, sorry. Okay, sir. These are the so by using for loop, I generating 1000 number of data. That means 1000 iteration. So that I set the minimum temperature and maximum temperature. By using this formula, I can generate a temperature. As the same message is once again I have to generate radiations because of the 1000 number of data, 1000 iteration. I am generating all the data. So after that, I have to collect. With the help of that corresponding irradiation input and output values are also I find it. Then I make a iterations. Once I successfully run, this is the data. Just I wish to run. So once I run the data, so once I run this program, these are the data are generated according to my input variable. Okay. So here, what are the things I record? That means G irradiations as well as this is input variables. Where it is.
Sir, it's a better disable
I
it,
want
sir.
to.
Yeah, disable the magnifier.
That is why I'm trying, sir. But
Yeah, in the scroll bar below, you cancel it.
where it's actually.
Sir, below magnifier is available. You cancel it, sir.
I tried this, sir, but I can't find them.
Yeah, now visible. Yeah, right click and close it.
Close it, sir.
Yeah.
Okay, now okay. Right.
And go to your slide.
1 minute.
Yeah.
Okay, circle testaments. Okay, right. Okay, this is a relationship between the temperature as well as irradiations. Okay, so temperature it will be around what is this 50 to 25 degrees centigrade, so that it will be like that. Then what is this irradiations? It will be vary from 100 to 1000. So this is the source relation between the irradiation and the temperatures. It is also a relation between the voltage and irradiation. This output data. Then I said that it will be in this block neural network is play important role for to track the maximum power. So that in MATLAB we have one of the option. The option is called as NN start. That means neural network start. It's one of the app. In that I'm using fitting app to develop a ANN. So this is first. If you are typing command window NN start, this window will be open. Okay. In that you click in next button. This window will be appear. It will be a small pop-up screen. Then later on, we have to select data, input data. That means input as well as output. Input means irradiation as well as temperature. That is input for train the neural network. Output is duty cycle is output data. Then whether we are then we have to split the data for training 70% of total data, and validation and testing is remaining 30% of data. Each is 15% of overall data. Then we have to select number of hidden layers. That is here I am using 10 number of hidden layers. Then here we have to train the neural network. Here I am using LM algorithm for train the neural network. If you click the train, it will be automatically trained. Okay. Once the training is over, we have to find the mean square error. So at the time of training, I find training data and testing data. It will be matched so that there is no error. Then I'm saying this is an MATLAB file as a what is a sibling file, because of I'm using here sibling. There are numerous options there, but here I'm using sibling diagram. Okay. Finally, it will become like that. Okay. Here, what is the role of this is neural network. It will generate duty cycle according to the input data. Okay. So input data it will be fed to the it will be control gate signals of MOSFET. Okay. So according to the switching device, the output voltage will be vary. So this is a PV/IV curve of solar PV model. I take little bit extra time. It's a PV/IV characteristics of solar PV model. Okay. So it is used to generate data sets. Here, what are the data we are using? So how we are trained the neural network? And then start. So here we have to select fitting up. Here I'm using fitting up. So it will be comes this slide that it will be welcome to neural network fitting up. That you got to click next button. Okay, here asking what are the input, what is the target value. So here we have to select the input. Here it is input as input. Then target is output. Then we got to split the data. Once again we got to click. Here hidden number of layer. Here default value 10. As it is I maintain. Then I train the neural network. It will be trained. Neural training is over. Here we have to select here LM algorithm, PR algorithm, SGC algorithm is there. I am using LM algorithm to train the neural network. So it will pop up. Training is going on for 1000 iteration. Training is over. So after that, I have to, if you wish to find whether any error is there, our training data means you got to go to the plot, regression plot. It will show the relation between our training data as well as available data. Whether it is matched or not, it will be matched. So there is no error because of either R values is equal to 1. So I am not considering any. So I train the proper manner. Then I click next. If it is error is there, you have to train once again. So there is no error, so that I am not trying once again. Just a click here whether it is the applications or code generation or sibling deployment. Here I am using sibling deployment option, so that I click the sibling deployment. So it will make this a sibling box. So you can what is this save it for future use. I'm save it already. I'm used it, so that I show you here. Here you got it. This is a NM model. So inside it is developed one thing. Already I said that what are the process we are followed. Same process. It will be developed one thing. Then here two input, that is the irradiation as well as temperature. Okay. Here we set the voltage. Okay. Here we filter which is used to remove the unwanted component. Here for we have to convert as signals for comparing purpose. Here it will be comparing. Then the output is fed to the PID controller. It will be tuned. Okay, according to all the error signals, PID controller is tuned and it will be generated duty cycle. Right. Okay. So just you have to I'm running the program. So corresponding output first to observe here. So So now what I maintain irradiation as a constant 1000. That is a constant value. There is no completely, there is not a dynamic irradiation. It is I'm using constant irradiation. So that G value I maintain 1000. So according to that it will be generating. So here one drop is there. Okay, it will be one drop is there. This drop is indicating that time duration. That means load. Here I am connecting variable load on the PV model, so that according to the load at first up to 0.3 seconds, load 1 is connected. Then after that load 2 is connected. After that load 3 is connected. Each and everything has some time interval. That is a time interval is here you got to see. Sorry. So up to that first one amplitude up to what insertion 0.3 seconds. First load is connected. What is the resistance of the load is 20. Then next load I would like connect after 0.3 to 0.6 seconds. It has resistance value 30. So this like variable load I was connected. So according to that the generation power will be vary. Okay. So this generation power 250 watt. Here I am connected approximately 250 watt. This is a panel rating. It shows relation between the voltage versus power. Okay. So at the time of proper irradiation will be there. It will be generated 1 kilowatt. So we have to compare that value and this is to estimate the efficiency of proposed technology. So up to that, what is the extension completed up to generation, boosting, and fit to the load. So further development is there. We have to convert as a DC to AC, and it will be connected to the grid. Okay, that model I am working on, still not yet complete. So further, if you further development is there, if anyone interested, you can join. You can get on essay publication in future. If anyone have doubt, please.
Yeah. Sir, if you have any doubt,
Yeah.
so you can interact with Mary Prashant sir. Okay, sir. Thank you, sir. So
Thanks, sir.
for your effort of presenting so the maximum PowerPoint tracker. So I thank you all the participants. Okay, with this today we will close this meet. So I request all the faculty members please join this faculty lecture series, and so we need your support. So thank you all.
Thank you, sir. It was a nice session by Dr. Mari Prasad.
Thanks, sir.
Thank you, sir. Thank you.